Okay, so this is a sixth video in the series of name reactions, and today we are going to discuss about Aldol reaction. So this is a question for you. I want you to convert this starting material into the following product. Take your time and find out the reagents required to convert this ketone into this alpha beta unsaturated ketone. So this is what we call the Aldol reaction. So let's begin. Let me give you another example. Suppose I have acetone and I'm reacting it with sodium hydroxide as a base. This reaction can also be done under acidic medium, a mild acidic medium, like hydronium ion you can take, that will give me H plus ions, and you will be able to generate this aldol addition product. This can also give me, through even CB reaction mechanism, this will lead to aldol condensation product. So now let's go ahead and see the mechanism under basic as well as acidic condition to convert your acetone into aldol addition product and aldol condensation product. Okay, so we have a acetone molecule and we are adding sodium hydroxide, and the aldol addition product is this one. So now let's see the mechanism. So this is my acetone and we are adding sodium hydroxide, that will give me hydroxide ions as a base, and this base will grab this acidic proton and will generate a carbon ion at this carbon. Now this carbon ion can go under resonance with this carbonyl and can generate a enolate ion. So we have now a enolate as a reactive intermediate. Now at this point of time, the another acetone molecule will come. This oxygen will form a double bond here. This double bond will attack at this carbonyl carbon and this bond is going to break. So simply we are regenerating our carbonyl system and we are connecting this carbon with this carbon. So now we have formed this one. We simply connected this carbon with this carbon, and this carbon has two methyl groups and one O minus. So we have just removed water here that can come back, and this time it can act as an acid and will eliminate HO minus. So now we have OH and two methyl groups. Now furthermore, so this is a aldol addition product. Okay, so this is a aldol addition product. Now we do have still hydroxide anions and we still have this acidic proton. So this O minus can take this proton, this bond can go in resonance with this carbonyl carbon, okay, and we have now oxygen bearing negative, a double bond here, OH and two methyl groups. Now this oxygen will reform a double bond, this double bond will migrate here and this bond is going to break. So this will give me the aldol condensation product. And this two steps, this one and this one, this is what we call the even CB reaction mechanism. So this is the mechanism of aldol reaction under basic medium. Now let's see the reaction under acidic medium. Okay, so we have acetone, right? And we are giving a mild acidic medium by using hydronium ion, and we are generating the aldol product. So this is a aldol addition product. So let's see the mechanism. Make sure you pause the video and give a try to predict the mechanism for this reaction. Okay, so let's begin. So we have acetone and we have this hydronium molecule. So this oxygen can take this proton, can neutralize oxygen, and this will give me this particular intermediate. So we just removed water and we have acidic proton, and water this time can act as a base, can take this proton, this bond can migrate here neutralizing oxygen. So we have generated a enol. So we have generated the enol intermediate. Okay. Now this particular intermediate will come back. Okay. So we have this particular intermediate which formed in previous step. So now at this point of time, this oxygen will reform a double bond, and this double bond will attack at this carbonyl carbon, opening up this bond. So we will get we are connecting this carbon with this carbon. This carbon has 2 methyl group and 1 OH. Now we have water molecule that can act as a base, can neutralize this oxygen, and will give me the aldol addition product. Now furthermore, so we have hydronium ions. So this alcohol can take this proton and can eliminate the water molecule, so that we have OH2. So this oxygen will get positive charge and we have 2 methyl group. Now water can act as a base. It can take this proton, this bond can migrate here, opening up this carbonyl carbon. So we have O minus, double bond, oxygen with 2 hydrogens getting positive charge, and we have 2 methyl here. Now this oxygen can reform a double bond, this bond can migrate here, eliminating water in a neutral form and giving me the final aldol condensation product. So this is the mechanism of aldol reaction under acidic medium. Okay, so now let's learn how to predict the product. Okay, so whatever we discussed, so we discussed that acetone under acidic or basic medium can give me this aldol addition product. So this is my aldol addition product. And we also know that this is a self-aldol reaction where this molecule reacts with itself to give this product. So in reality, 2 molecules of acetone are reacting to give me this product. So this is what we call the self-aldol reaction. The molecule is reacting with itself to form the product. So now let's learn how to predict the product. Okay. So all you have to do is connect your alpha carbon with the carbonyl carbon of the second molecule. That's all you have to do. You have to find out the alpha carbon, that is usually the adjacent to the main functional group. You have to connect that alpha carbon to the carbonyl carbon of the another molecule. So let's connect them. So I'm connecting my alpha carbon to this carbon, that is a carbonyl carbon, and you have to convert it into OH. And this carbon also contains 2-methyl group. And guess what? We got the product. So that's all you have to do. Connect your alpha carbon to the carbonyl carbon and make it OH. That's it. So this is a aldol addition product. For aldol condensation product, you first need to draw the aldol addition product, and then you have to remove OH group and keep a double bond in such a way that it forms alpha beta unsaturated functional group. So this is a alpha beta unsaturated functional group. Okay, so now you know that how to quickly draw the aldol addition product and the aldol condensation product. For aldol condensation, just remove your OH and keep a double bond next to this carbonyl group and you will get the product. So this was the example of self-aldol condensation. Okay, so when we have a acetone molecule reacting with itself under acidic or basic medium, I'm going to connect this carbon with this carbon and will convert this carbonyl into OH. So this is what we call the self-aldol reaction, and you get one product in self-aldol reaction. Let's talk about cross-aldol reaction. So for example, I have this as one of my ketone and this as one of my aldehyde. So what are the mixtures of product we are going to get? Okay, so this molecule do not contain any alpha hydrogen, right? Because this is a aldehyde and here we have a benzene group. But this molecule contains 2 alpha hydrogen, one at this position and one at this position. So now let's go ahead and connect this center with this carbonyl carbon to get my first product, right? And this carbon with this carbon to get my second product. So we are going to use our trick. Connect this alpha carbon with this carbon, convert it into OH. Correct? So this carbon contains 1 methyl group, that is here, and I connected this carbon with this carbon and converted into OH, and this carbon also contains pH. So this is my first product. Now let's connect this carbon with this carbon. Basically you have to connect your alpha carbons with the carbonyl carbon. So this time the product will be connecting this with this. So let me keep this part as it is. This carbon with the following carbon, convert this into OH, and this also contains pH. So this is my second product. So what do you think? Are we getting 2 products or more? Well, this is a cross-aldol reaction. But this molecule can also do self-reaction and will give me 2 more products. So total will have 4 products for this reaction. So let me draw them. So this molecule can react with itself from this center as well as from this center. So let's react it from this A site first. So connect this carbon with this carbon, convert it into OH. correct? Similarly, let's use B side, connect this carbon with this carbonyl carbon and convert it into OH. So this is my third product and this is my fourth product. So for this cross Aldol reaction, we are total of getting 4 products, where 2 is when this molecule reacts with this one and 2 product is when this molecule reacts with itself. A kind of self Aldol reaction in a cross Aldol reaction. Okay, so here's another question for you. So this is my one of the ketone. And I'm reacting this with this one. So what are the products we are going to get? Pause the video and try this reaction. Find out all the possible products. Okay, so let me call this molecule A and this molecule B, right? And let me call this center the alpha center A, this one B, this center C and this center D. Now A molecule can react with itself from A center. So this will be my first product. Now A molecule can react with A molecule from B center. This is my second product. Now A molecule can react with B molecule from A center. This is my third product. A molecule can react with B molecule from the B center. This is my fourth product. Similarly, B can react with itself from C site, another product. B can react with B from D side, another product. B can react with A from C side. B can react with A from D side. So we are going to get total of 8 products. So now let's go ahead and draw all of them by using our short trick. Make sure you draw them by yourself and then later come and check whether you have got all the product right or not. Okay, so let's draw when A react with A from A side. So this is my molecule A reacting with itself from the A side. So the product will be connect this carbon with this carbon and convert it into OH. So this is my first product. Let me box it. Now A can react with A from B side. So this is my A reacting with itself from B side. So connect this carbon with this carbon, convert it into OH. So this is my second product. Now A can react with B from A side. So this is my A and this is my B. Reacting from A side. So connecting this carbon with this carbon and converting into OH, and rest will be same. So this is my third product. Now A can react with B from B side. So this is my A, this is my B from B side. So connect this carbon with this carbon, convert it into OH, and rest will be same. So here we have OH. So this carbon is this carbon. This has one OH, CH2 CH2 pH, and CH2 CH2 CH3. So this is the another product. Okay, now the B can react with B from C side. So this is my B. Okay, reacting with itself from the C side. So connect this carbon with this carbon and you are done. So this is my another product. I'm running out of space. Now B can react with B from D side. Okay. So this is my D side, connecting this carbon with this carbon, converting it into OH. This is my another product. Now the B can react with B from this, B can react with A from C side. So this is my B reacting with A from the C side. So connect this carbon with this carbon and rest will be same. So this is my another product. And the last product will be B connecting to A from the D side. So this is my B. This is my A. Let's connect them from D side and the product will be this one. So we talked about reaction mechanism, then we talked about self aldol, we talked about cross aldol, we have also learned how to quickly predict the product. Now we also need to understand something called intramolecular aldol reaction. So now let's go ahead and check it out. Okay, so let's talk about the intramolecular aldol reaction. Let's say I have this molecule. Okay, so we have two aldehyde group present in the same molecule, and if I do the aldol reaction in presence of sodium hydroxide or the hydronium ion, the idea will be the same. So this is my alpha carbon. I'm going to connect this with this carbon and will convert into OH. So connecting this with this one. So we are forming a ring here. That will be 1, 2, 3, 4, 5 and 6. So we are forming a 6-membered ring. So let me draw a 6-membered ring. Let's say this is my 1, 2, 3, 4, 5 and 6. At 1 we have a aldehyde group. 2, 3 we have nothing, 4, 5 nothing. At 6 the carbonyl is now converted into OH, and this is the product. If you want to do aldol condensation, just remove this OH and keep double bonds in such a way that it forms alpha beta unsaturated aldehyde. So this is the product for this reaction. Let me give you another example. Let's say this time So earlier we had two aldehyde group in the same molecule. This time I am keeping a ketone and an aldehyde group. So feel free to pause the video and find out the all possible products. Okay, so let's begin. So we have one alpha center here, here and here. Let's call this A, B and C. Let's draw the product from A. So connect this carbon with this carbon, okay, connecting this alpha carbon with this carbonyl carbon and converting into OH. So we are forming a 1, 2, 3, 4, 5, 6, 7, 8. We are forming a 8-membered ring. So this is my 8-membered ring. So this is my 1, let's call it 1. Then at 2 we have a carbonyl group. 3 we have nothing. 4, 5, 6, 7 and at 8 we are converted carbonyl into OH. So this is my product coming from A structure. Let's draw the structure from B. So now at this point of time we need to connect this carbon with this carbon and converting into OH. So this time we are generating 1, 2, 3, 4, 5, 6-membered ring. So quickly draw the 6-membered ring. Okay, let's call it 1. So this 1 contains this whole ketone. Okay, at 2 we have nothing. At 3 we have nothing. 4 nothing. 5 nothing. At 6 we converted this carbonyl into OH. And this is the product for B. Now let's connect from C. So this carbon will attack at this carbonyl and convert it into OH. So this is 1, 2, 3, 4, 5 and 6. A 6-membered ring. Let's call it 1, 2, 3, 4, 5 and 6. At 1 we have a aldehyde. At 2, 3, 4, 5 we have nothing. And at 6 we have a methyl group and we converted carbonyl into OH. So this is the product, a intramolecular aldol reaction. So we are getting 3 products here coming from A, B and C. So we kept 2 aldehyde group, 1 ketone, 1 aldehyde. Now let's see both the side ketone group. Okay, so suppose this time I have this one. And I'm doing aldol reaction. So pause the video and find out all the mixtures of product. Okay, so let's begin. So I have this alpha carbon A, this one B, this one C and this one D. So let's draw from all of them. So let's start with A. Okay. So I'm going to connect this with this one and we'll convert it into OH. So we have from 1, 2, 3, 4, 5, 6 and 7. So we have formed a 7-membered ring. Okay, let's call it 1, 2, 3, 4, 5, 6, 7. At 2 we have carbonyl group. 3, 4, 5 we do not have anything. 6 nothing. At 7 we have 1 methyl and we have now OH. Let's connect it from B. So this is my B center. Let's connect it and convert this into OH. Also contains 1 methyl group. We have 1, 2, 3, 4, 5-membered ring this time. So we have a 5-membered ring. Let's say this is 1, 2, 3, 4, 5. 1 contains this ketone. At 2 we have nothing, 3 nothing, 4 nothing. At 5 we have 1 methyl and 1 OH. So this is the second product. Let's see the C1. So connect this carbon, excuse me, we have C this one, excuse me. So let's connect this one with this thing and convert it into OH. So 1, 2, 3, 4, 5. And now we have, let's call it 1, 2, 3, 4, 5. At 1 we have ketone, at 5 we have a methyl and OH. So these two are same, exactly same. Let's draw from D. So this is my D center, connecting this with this, making it OH, and this will give me a 7-membered ring. 1, 2, 3, 4, 5, 6, 7. And we are going to get the same product as this one. So in this reaction, we are getting total of 2 products only. That is this and this. And why is that? Simply because I have taken example of a symmetrical ketone. If you see, we have a symmetry plane here. So this is equivalent to this. These two are equivalents. So we have a symmetrical ketone. That's why we got only 2 products. If we had a unsymmetrical ketone, for example, if I keep a methyl group at C, then we will have total of 2 more products and total of 4 products. And the idea will be the same to getting this product. Okay, now I also want you to talk something important, because in exams your professor might want to trick you. So he may phrase a question like this. He will give you 1 ketone and 1 aldehyde, okay, and he will tell you, so basically we are expecting 2 products because we have 2 alpha carbons. This molecule do not have any alpha carbon. So if we go by A and B, we have 2 products. If we go by A, let's draw it. So this connect this carbon with this carbon and convert it into OH. So basically we are doing cross aldol only for a time being. Okay. If we do self aldol also, this molecule will react with itself and will give 2 more products. But let's talk about cross one only. So if I connect by A, this will be the product. If I connect by B, this will be the product. So my question to you is, which base should I use? Which base should I use to get this one as a major product? So I want you to know that we have seen the mechanism and we know that the reaction goes via enolate chemistry or the enol, right? So for this molecule, the enolate can be drawn in 2 ways. First coming from A and second coming from B. If it goes via A, we'll get this as major product. Then we will attack from here and this carbon will get connected. If it goes via B, we'll get this as a major product simply because this will attack and this will get connected to this carbon. So how to know that which product is going to be the major one? So idea is simple. You need to remember that bulky bases like organic bases like LDA, these kind of bases will form the less hindered enolate, okay, or the outside enolate, because LDA is a bulky base. This will abstract the proton from the less hindered side. But if you take the less bulky base Like inorganic bases like sodium hydroxide, they are small in size. They can go inside and take away the proton from B and giving me this enolate as a major, and this will lead to the B product. Okay, so I hope I'm clear that if you want to connect from the outer side, you need to use the LDA or the organic or the bulky base, and if you want to connect from the inner side, you have to use the less bulky base like NaOH. So here we'll need LDA and here we need NaOH. Feel free to ask the question if you have any in the comment section, and I will be very happy to answer it. Okay, so that's it for today. We discussed in detail about aldol reaction, aldol addition and aldol condensation. And we also seen the mechanism, a short trick to predict the product. So that's it. Thank you for watching.